Hello friends, we have already discussed about transpose of a matrix in the previous video. So in today's video we are going to discuss about an associated property or which is associated with the concept of transpose of a matrix, which is the symmetric and skew symmetric matrix. Okay, so first let us discuss about symmetric matrix and then we'll go to skew symmetric matrix. Now, a symmetric matrix is one. Let us say we have a matrix A. It will be called as symmetric if the transpose of this matrix is equal to the matrix itself. That is, when we calculate the transpose of matrix A, we will get the matrix A again. We will get the same matrix again. Okay, so let us see some examples of symmetric matrix. Let us say this matrix 1, 1, minus 1, 1, 2, 0, minus 1, 0, 5. Okay, this is matrix A. Okay, suppose now we calculate its transpose. So how transpose is calculated? We interchange the rows and the columns. So the first row, it becomes the first column of the transpose matrix. The first row will become the first column. The second row will become the second column. The third row will become the third column. So you see, both the matrices, they are the same. 1 1 minus 1 1 1 minus 1 1 2 0 1 2 0 minus 1 0 5 minus 1 0 5. So we calculated a transpose of matrix A and we got the same matrix back again. So this is a symmetric matrix. Okay, another example of symmetric matrix is 3 minus 2 4 minus 2 6 2 4 2 3. Okay, so this is a matrix, let's say B. Now B transpose, we replace the rows with the columns. So the first row becomes the first column, 3 minus 2 4 minus 2 6 2 4 2 3. Okay, so let us compare 3 minus 2 4 3 minus 2 4 minus 2 6 2 minus 2 6 2 4 2 3 4 2 3. So we got the same matrix back again by the transpose of matrix B. We got the same matrix B again. So this is also, matrix B is also a symmetric matrix. So this is the basic definition of the symmetric matrix. A transpose is equal to A, means the transpose of a matrix is the matrix itself. So this is the concept of symmetric matrix. So now let us discuss about skew symmetric matrix. We have already discussed about symmetric matrix. So let us say we have a matrix A. This matrix A will be called as skew symmetric if the transpose of the matrix gives us the matrix again, but A again, the same matrix, but with a slight modification. It is multiplied with a scalar quantity which is minus 1. So basically A transpose gives us the negative of the same matrix. The elements will be multiplied with minus 1. This is the basic definition of a skew symmetric matrix. We have already discussed about multiplication of a matrix with a scalar quantity or a constant quantity, so you please check out that video. So the skew symmetric matrix, the definition says that the transpose of a skew symmetric matrix gives us the negative matrix, the same matrix, but each element will be multiplied with minus 1. This is the definition of a skew symmetric matrix. So let us now take some examples of skew symmetric matrix. Let us say we have a matrix A which is given by 0, 1, minus 2, minus 1, 0, 3, 2, minus 3, 0. This is the matrix. The transpose of the matrix will be same concept. We will replace or interchange the rows and the columns. So first row becomes the first column, 0, 1, minus 2, minus 1, 0, 3, 2, minus 3, 0. So as you can see here, if you compare both the matrices element by element, you will see that in the transpose matrix, each of the element is multiplied with minus 1 with respect to the original matrix. So 0 will stay as 0 because multiplication of 0 with anything yields us 0. This one here, it is here minus 1, means it is multiplied with minus 1. Here it is minus 2, here it is plus 2. Minus 1 multiplied with minus 2 gives us plus 2. Here it is minus 1, here it is plus 1, means here also it is multiplied with minus 1. 0 will stay as 0. 3, here it becomes minus 3. 2, here it becomes minus 2. Minus 3, it becomes 3. 0 will stay as 0. So each of the element in the transpose matrix are multiplied with minus 1 with respect to the original matrix. So it is basically the same matrix magnitude wise, means magnitude of each of the element is equal, but only difference is that each of the elements of the transpose matrix are multiplied with minus 1 with respect to the original matrix. So this is a skew symmetric matrix where A transpose is equal to minus A. Another example of the skew symmetric matrix, let's say we have another matrix B is equal to 0, 3, 4, minus 3, 0, 7, minus 4, minus 7, 0. Okay. So now transpose of B will be rows, the first row becomes the first column, second row becomes the second column, third row becomes the third column. So 0, 3, 4, minus 3, 0, 7, minus 4, 7, 0. So here also, if we compare both the matrices element by element, we will see that in this matrix each of the element is multiplied with minus 1 with respect to the original matrix. So you see here 0 is 0 because multiplication of 0 with anything it becomes 0. 3, here it is minus 3 multiplied with minus 1. 4 becomes minus 4 multiplied with minus 1 again. Minus 3 becomes 3. Minus 3 into minus 1 is 3. 0 will stay as 0. 7 becomes minus 7, sorry. Here it is minus 4 minus 7, 0. this is by mistake. So 7 becomes minus 7, minus 4 becomes 4, minus 7 becomes 7, and 0 will stay as 0. So again here in this matrix, magnitude wise each of the elements are the same, they are equal, but only difference is that each of the elements in this matrix, the transpose matrix, is multiplied with minus 1 with respect to the original matrix. Okay, so this is the basic definition of a skew symmetric matrix. Okay, in symmetric matrix, A transpose is equal to A, means the transpose of a matrix gives us the same matrix exactly. In skew symmetric matrix, A transpose is equal to minus A. It means it will give us the same matrix magnitude wise, but each of the element will be multiplied with minus 1. Okay, so this is all about skew symmetric matrix.